Okay, let's get started today. We are finishing up a discussion of the theoretical underpinnings of the relational model by talking a bit about views. I'll go through it pretty quickly because I think it's a little more understandable when I can present it with some real data. So next week we can do that. And then we're going to get into talking about the SQL query language and introducing it to you today. We'll get through simple operations on a single relation today. And if we're really moving rapidly, we may get to joins which involve multiple relations, but good chance we will finish up when we finish all the operations on single relations. So you may remember the relational model represents the so-called data definition language for the relational model. And last time we said that we represent our, let me get this up. We represent our data using tables. And the formal name for that in the relational model is a relation. And what are the rows called? Tuples. And what are the columns? Attributes. Good. So we represent our data as tables, and we call what you see here, these relations, we call them so-called base relations. These are the ones physically stored in files on the database. Now, sometimes this isn't the best way to present the database to a user. For example, we may not want anyone but a manager to be able to see the salary field. So we may not want to be able to present the full set of relations to a user, or conversely, we may want to present a series of reports to users. And the way we can do that is through something called a view. So it is a way to construct so-called virtual relations. So a view, I don't have it up there, and the ink doesn't work too well, so I'm just going to say it. You may want to put in your notes. A view is a virtual relation. It is formed from underlying base relations. So we make a distinction here. Let me type it. So we're going to make a distinction. Here I have notes. So we're going to make a distinction between a base relation versus a view. Okay, so a base relation is an actual physical file somewhere on the file system. A view is a virtual relation formed by some sequence, if I could spell correctly, some sequence of operations on one or more base relations. So a simple example is to have a view of the branch relation with the salary field removed. Okay, so that would be a virtual relation with simply the salary field removed. And I'm not sure if I can make this bigger for the back of the room or not. Let's see. Tedious way to do it. Nope, sorry. That's the biggest I can do. Okay, so the first thing they can do is they can help with security or with not with hiding details we don't want people to see. They can also simplify complicated operations on base relations. So again, it's easier to show this when we get to some real data, but right here, let's say we wanted to display the set of branches. Let's say we wanted to display the, what do we want to do? We want to display all staff members and the address at which they work, okay? Well, looking at these two relations, that's not particularly easy. I can see John White. Now I have to go up to B005, find out that he's at 22 Deer Road. So this isn't a particularly helpful way to view the addresses at which each of the staff work. So it might be nice to construct a view, a relation that had two columns, and the two columns would simply be the staff member's name, first name, the first name, the last name, and their address. So this would be an example of a view. Okay. That relation does not exist in the database, but it would be something that could be displayed to the user. So this would be a view that might be more useful for some reason, like a directory. This could be a directory view. Okay. Or I have some other examples down here. Let's say that I wanted a report that shows the average salary in each branch. Okay, well again, that's not, I can't even easily get that here, but I could create a view that simply shows the average salary for each branch. So views have a way of simplifying the information that we present to our users. Okay, so they can also sometimes be thought of in the context I just showed you as a report. Okay, so a salary report or a directory. Okay, so two ways to think of them: A, as a virtual relation; B, as a report. Okay, when we construct views, we want updates to the base relation to filter through to the view. If I change the branch at which John White works, then in the directory view, the street address should update for John White. Okay, if I update a salary for John White, then the average salary at the branch at which he works should be updated. Okay, and conversely, if I update the view, so I kind of have this situation of a base relation and a view. So if there's an update over here, that should reflect over in the view. Conversely, if I update something in the view, then that should update the base relation. But as we'll see, there are restrictions on updates to views. For example, if I have a view that is the average salary, so let's say that for branch B003, the average salary is 20K. If I update this average to 25K, what's the problem with updating the base relation? It doesn't know which salaries to change in the base relations, because this was a many over here, this was a many to one mapping. So the problem often in a view is you can't map back because it's easy in the base because there's many, but then in a view you're often aggregating a result. So if you change an aggregated result in the view, you can't figure out which tuples to apply it to in the base. So oftentimes we actually are not allowed to modify the view. There's a lot of restrictions on when and when you cannot modify a view. Okay, and on cue, here are some of the restrictions. So first of all, to make things simple, we only allow a view to change a base relation if the view was derived from one base relation. Okay, I gave you an example. The directory relation was derived from how many relations? 2. So I couldn't change that view because it came from 2 base relations. So we're only allowed to modify a view if it comes from one base relation. And the query or the view must contain the candidate key. Okay? That allows us to uniquely identify the tuple in the base relation that is being modified. So we can only modify tuples in a view if they contain a candidate key from the base relation. So here B003 is a candidate key, so that would satisfy that, but it's not going to satisfy this condition because of aggregation. But we need to be able to identify uniquely the key, or tuple rather, being modified in the base relation. Okay, and then C is we can't update a view's columns when it was formed from aggregation because we can't disaggregate. We can't map from one to many. Okay, so that's a quick introduction to views. We will see them in more detail a week from today when we talk about our SQL and views. And Elvis, I didn't mean to keep you. I'm sorry. You can take off. Elvis generously agreed to extend his office hours by a few minutes to help people with the databases. Okay. So moving on, that finishes up with the relational model. And now we're going to move into talking about the SQL data manipulation language. If only I could get it to come. For some reason, it is moving my PowerPoint slides to the end of my display, and then I can't get at them. Okay. Please work. There we go. Except we're way, way in the wrong place. Okay. Now we're in the right place. Okay, so actually it may not help so much. The queries on these slides are from page 112 of the textbook. If you have it, you can open it, but a lot of the queries I'm going to do are going to be from the relations I created last time, the student courses and courses relation. So it's not as important to have the book as you might think. Okay, so we are going to be talking today about retrieving data. We'll talk next time about inserting, updating, and deleting data. And the relational model boils down to 3 fundamental operations. Select, which filters the rows. So I might want all people with salaries greater than 100,000. So that, if I have a relation and I have some number of rows, then select is going to select some number of rows. Project is going to select some number of columns. So project is an operation on columns. It returns some number of columns. Select filters the rows, so they're orthogonal. And then join is a way to combine information from multiple relations. Today, as I said, we're primarily going to focus on single relation queries. If we have time, at the end we'll get briefly into joins for sure. Next Tuesday we'll talk about joins. But these are the three basic operations that the entire relational model is based on. Okay, and then the key commands: select, insert, update, delete. Again, we're talking about select today. And when SQL was designed, it was designed to be written and read by non-programmers. So it is verbose, and it has a lot of standard English words to it. So here's three sample queries. The first one creates a new relation. And notice it doesn't say create relation. It says create table, because that's the view or the terminology we use for end users. So here we're creating a table called staff that has three attributes: staff number, last name, and salary. You can see this is what's called a variable character field of maximum length 5. It means that the maximum length is 5, but that when it's stored in the database, if the staff number is only 3 characters, it will occupy only 3 characters. If instead I said fixed char, then even if the staff number was only 3 characters, 5 characters would be allocated to it, and there would be 2 blank spaces. So that's the difference. When we get to the data definition language next week, we'll talk more about why you might use one or the other. And then this is decimal, saying that there's 7 digits total, 2 of which can be after the decimal point. So we're saying that no one can make more than $99,999.99. Okay? Now, if this were C++, we couldn't do this. We'd have to say float or double. But this is meant to be more for end users. They think more in terms of decimal numbers like this. You actually could declare salary as a float, but salaries actually are to the penny. Hence, it's a little more reasonable to declare it this way. So here's a sample insertion command: insert into staff. And we're inserting a tuple with the values SG16, the last name of Brown, and a very paltry salary of $8,300. Hopefully that's a monthly salary. And then here, this is a sample selection. Select staff number, last name, and salary from staff where the salary is greater than 10,000. And this already is showing select and project. So right here, this is the projection. It's saying that we want only these 3 fields. Now I understand those are the only 3 fields in this particular relation, but it could have been a subset. And then this is select. So this is the project, and this is the select operation. So that's filtering the rows so that we're only looking at people whose salary is greater than 10,000. Yes?
If you wanted to look at only staff number and last name, but you only wanted to look at those with salary greater than 10,000, can you do a where on something that's related to those fields even if it's not in your select?
Yes. So the question was, let's say I wanted to just look at the last names of people whose salary was greater than 10,000, but I don't need to see the salaries, that kind of.
Yeah.
So that is perfectly fine. I could have simply written the query so that it shows, in fact, I could have written it like this. So select last name from staff where salary is greater than 10,000. So I don't have to have the attributes in the where clause do not have to appear in the select. Other questions about this? Okay. Okay. The only thing that's really important here is about case sensitivity. The only thing that is case sensitive in our version of MySQL is relation names. Everything else is case insensitive. For example, if my last name starts with a capital V, if you type in lowercase v, A-N-D-E-R, it will match. If the field name is, say, capital L for last name, and you type in a lowercase l, it won't complain, it will match. However, if the relation name is student with a capital S, and you enter a lowercase s, it will complain. I hate that because that's inconsistent. Being from the world of my research area is graphical user interfaces, where consistency is everything. So why they only care about case with relations is beyond me, but that's the way it is. Oracle is also case sensitive for field names and literal character data, but hey, we're not using Oracle, we're using MySQL. And the only thing that our version of MySQL is case sensitive for is relation names. Now, when you write your SQL commands, please indent them nicely, just like you would indent your code nicely. So back here, that was not indented nicely. Okay, actually the first one was indented nicely, but query 3 was not indented nicely. You would like to see the from and the where nicely indented. So let's see if I can, no, I don't have it, but the MySQL interpreter even forces you to do things. So if I say select star from student where GPA is greater than 3, it's doing a little bit of indentation. Okay, so in general, indent your queries nicely. Or over here, actually, I can show it right here. Select student ID, blah, blah, blah. The important thing is you have nice indentation. So each clause is on its own line and is nicely indented. Makes it easier to read. Okay, and also if with indentation, if you have multiple queries in the same file, makes it easy to see where one query begins and one query ends. Okay, so that was essentially what this part says. If a clause has several parts, then put them on separate lines, nicely indented. Now, 311 was required as a prerequisite, although I'm not sure. Did they go over grammars in 311? Okay, so don't worry if you actually didn't go through 311. The way that many technical documents are written in computer science is to express commands using something called BNF notation for Boyce. Is it Boyce normal form? I'll say Boyce normal form, but I may be wrong about that. At any rate, it stands for a normal form representation, and it's really a grammar. And once you get used to looking at it, it's very simple to read. So uppercase letters are reserved words, lowercase are user-defined words. The vertical bar indicates a choice. Curly braces indicate required elements. Square brackets indicate optional elements. And dot, dot, dot indicates optional repetition, so 0 or more, kind of like what we do in the English language. Okay, so as an example, here is the so-called formal definition for the select statement. So select is in uppercase letters. It's a reserved keyword. Okay. Column expression is in lowercase. It is a user-defined keyword. New name is lowercase. It's a user-defined keyword. Distinct and all are in square brackets. It means they're optional. If you do choose to use what's in the square brackets, you'll notice that there's this vertical bar character. So it's saying that you can use either the keyword distinct or the keyword all, not both, one or the other. Okay, after the select statement and this optional keyword is a curly brace. So it says that what must follow is a mandatory list of attributes. Okay, so the attributes, it's saying it could either be specified using an asterisk, which means what for those of you familiar with regular expressions? Everything. Or, vertical bar, you can give a list of column names. So column expression turns out to, for the most part, be a column name, but you're allowed to use arithmetic. We'll show you later. You're allowed to change the name of the column. That will be helpful. So we will show with aggregation, you might say sum salary, and if you don't rename it, it will literally appear as sum salary. That may not be a particularly good column name. So you could say sum salary as total salary. And then when it actually appeared in the report, it would appear as total salary. So the as allows you to give a more meaningful name to the column. And you'll see again, it is in square brackets, making it optional. And then you can see there's a continuation that is a comma, dot, dot, dot. So that means you're allowed to have a repetition of one or more columns that are comma separated. Okay? Then the whole thing here was optional, although generally you would not have a select statement that had no attributes specified because you'll get nothing in the report. Not really clear on why they made it optional. Okay, so that's how to read this. Okay, once you get used to it, it's not very difficult to read. Okay, and then the rest of it is saying we select from some sets. We select, what this is really saying is that we are selecting, hey, I wonder if this would work. Try not. Let's see if I'm good with this. No, I'm not. I can't finger do it. So there's someone, is anyone familiar with the Khan Academy? That person became really good with actually being able to write with a mouse. I'm not, so I won't try. So instead, we will simply say select, this is really saying select attributes. So this is an attribute list from a table list, so a list of tables. Where is our filter? Group by, we will see, is good when we want to organize rows into sets. So for example, if we go back to our branch, here we go. There we go. So you see here we have branch 5, branch 3, branch 7. Sometimes we want to treat all rows with a particular branch similarly. So the group by allows us to, in effect, group tuples into sets based on a value. So here we might group tuples into a set based on branch number. And that's useful for getting statistics like the cumulative salary for each branch, or the average salary for each branch. So group by allows us to group rows into sets and then to get some kind of operation on that set, like min, max, sum. So that's what the grouping by is useful for. And then order by sorts. So sometimes when we display a result, we want it sorted on last name, salary, some other attribute. So that's the basic set of things you can do with a select statement. And we'll go through what these different clauses mean in a moment. But first we have to finish up a little bit of housekeeping. In SQL, you should get used to putting your string literals in single quotes, not double quotes. The reason is that in real SQL, double quotes is interpreted by the query optimizer as specifying the name of an attribute, because attributes are allowed to have spaces in real SQL. And the only way then, if an attribute has spaces in it to indicate where it stops and ends, is to put quotes around it. So real SQL says that string literals are enclosed in single quotes and attribute names are enclosed in double quotes. MySQL is not picky that way, so it will allow you to get away with putting double quotes around your character literals. I don't want you to do that. I want you to get into the correct habit of putting single quotes around your character data. And the reason I'm emphasizing this, why do you think I'm emphasizing this? What do you normally do with a character literal in a CS program? Double quotes. So you got to break yourself of that habit. Okay, that's the only big deal there. Okay, so I already talked about the various parts of the select statement. And rather than going through, actually, this order of the clauses cannot be changed. So when they were presented here, they have to appear in that order. I can't say select where from. It has to be select from where. Not a big deal. You'll get used to that. Only the select and the from are mandatory. Okay? So in fact, what I'm going to do now is start running through some examples, because I think it's just more interesting to look at examples than it is to see a whole bunch of slides. So I've logged into my database. I'm using 3 relations, so I will show them to you. Select star from student. So I'm selecting all the columns. So that's first name, last name, ID, and GPA. Another one is select star from courses. So the courses is course ID, course name, and location. You can tell that when I started this course, we were located in Claxton, and I have not updated it to Mingao. And the final one is something called student courses. And it is a list of students, the course they're in, and the grade they got, and their raw score in the course. So I have 3 relations that I'm going to be dealing with. And you can already see how I'm using the select with no where, and it is giving me all rows in the relation, and I'm also getting all attributes. But let's say all I want is the score. Actually, let's do something a little less. So select star from student. Let's now just select first name and last name. Uh-oh. There we go. From student, and we just get first name and last name. Okay, simple enough. Now, let's just select last name from student. Okay, and you'll see something interesting there, which is, in fact, let's make it a little more obvious. I'm going to use an order by to make it brutally obvious. There's actually a bit of a violation here of relations. What is the violation? It's actually giving me a table back, but based on what I said last time, this wouldn't actually be a real relation. It's got duplicate tuples. Okay, now users aren't going to worry about the nuances of the relational model. So we are happy to return views that don't conform to the relational model. But we don't always want to see duplicates. So that is where we can use select distinct. And now you see mouse shows up only once. Remember that there was also select all, but by default, all is used, so you don't have to specify it. But distinct gets rid of duplicate tuples in our output, so we don't have to look at them. Okay? Well, we often only care about some subset of the tuples. So, for example, we might care about only the courses being taken by one of the mouses. So let's actually look at, again, the student relation. So let's say we want all courses being taken by Minnie Mouse. Her ID is 2, so I'm going to select star from student courses where, now I have to go back to look at what the ID was. It is student ID, so where student ID equals 2. Okay, so Minnie Mouse, her ID is 2. Select star from student courses where student ID equals 2, and that returns the 2 courses that Minnie Mouse took. Okay. Or I can, so that's pretty simple. And in fact, you can use any of the relational operators, greater than, less than. One special thing though, select star from student courses where student ID not equal to. Okay, that did work. So you can use not equal. So all relational operators work, yes.
Earlier you wrote a command like this where you put a clause on a separate line.
Mm-hmm.
So is the interpreter waiting for the semicolon? And if
yes.
So, can you break the command? Can you break a clause up? Is that
yes. So I could say select star from. Okay. You get the point. Yep. So it's just waiting for more input. Pardon? That's a good question, actually, because it seems that everything you do that would get out of it takes you completely out of the interpreter. So, good question. I don't actually know the answer to that. Usually what I do is when I'm in that situation, I just put a semicolon knowing it's going to cause a syntactic error, hit return, and then retype it.
\C. I saw like a \C once.
Really? Select star from... \C does the trick. All right, I'll try to remember that. Thanks, Luke. Okay. So we also are allowed to use the Boolean operators. So the Boolean operators are or, and, not. Okay, so let's say that I wanted to select star from student where last name equals Vanderzanden or last name equals cat. Okay, notice first of all, I'm being case insensitive. I'm using the single literals, and I get the two that are van der Zanden and cat. Okay, I can use and. Yes.
Can you do character arithmetic? Can you say I want to look at all grades that are greater than a C plus or something like that?
Let's find out. So the question is, can we use the greater than with character arithmetic? So the question is, can we look at all grades greater than? It's not going to work properly though, even if it, yes, okay. So yes, okay, so the question is, let's say we say select star from student courses where grade is greater than B. It's not going to give you the result that you think you want. You want everything that's an A or a B, right? But you're going to actually get everything that is B, C, D, F, because it's using lexicographic ordering. And you actually might pick up some A minuses depending on, you won't do it here actually because, but you,
So if you did less
it,
than though.
then you would get it. You would get everything that was a A.
Okay.
But you have to base it on lexicographic ordering rather than your intuitive.
I was
Yes.
going to say, since the actual numerical scores are stored in there, you can just figure out numerically
Right.
what is an A or a B, and then use that just like greater than that number.
Right. That would work too.
I was thinking
So.
more of the case where you don't have like,
Yeah.
values,
He
so
basically he wanted to know whether you could do non-numeric comparisons, and the answer is yes. Okay. Okay, so you can say select star from student where last name equals van der Zanden, and I'll do or last name. Actually, you have to do it like this now. Not last name equals cat. So you're now using Boolean operations to do it. So I'm going to get actually everything that's not cat. And I could have said or last name like that too. It would have worked equally well. I just wanted to show that you're allowed to use Boolean operations and not is one of them. Okay, so it's a little confusing because if it's a relational not, you're using the bang character, and if it's the Boolean not, you're using not. Okay, and they're not interchangeable. So that's kind of frustrating. Okay, now there are some simple shortcuts. So for example, back here, I was asking for things that were van der Zanden or cat. That's a little verbose. I could say where last name is in the set van der Zanden, so I can give a comma-separated list. So that's helpful rather than having a long series of ors. I can simply ask whether an attribute value is in a comma-separated list of values. Actually, this last name should not be equal to cat. So I'm just giving a comma-separated list of literals. Same thing. Okay, or I could say select star from student where GPA is greater than equal 3 and GPA is less than equal to 4. But that's a little verbose or hard for people who are not programmers to do. So I can also say where GPA between 3 and 4. I don't care which you do. As programmers, you may well find the first way of saying it easier. But for people not mathematically inclined, between 3 and 4 may seem easier. And I don't care what you use. Between is inclusive, so you see that between picked up the 4 and the 3. And I hate between. I think it's imprecise. But it is what it is, right? SQL was designed for non-programmers. I prefer the precision of greater than equal and less than equal. I do not care which you prefer. Use either one. Okay. Believe it or not, I do like in. I find that to be very concise, compact, and in conformance with using sets. Okay, and let's say I wanted to find all CS courses. So I want to select star from courses, but I only want CS courses. So there I would say where course name, like, and now I can say, I can use what are called wildcard characters. So the percent says match anything before the CS, and the percent afterwards matches anything after. So it's saying, I want any tuple where the course name has something with CS in it. Okay, in this case, only CS 100 was like that. Is that really true? Wait, why did I only get...
You want a course ID?
Ah, thank you. Change that to course ID. Now we get all the CSs. Okay, I could have also put it so it was just at the beginning. So it would have said now in this case it has to start with CS. And I can also use a underscore, in which case it will match any character but just one. So percent says 0 or more. The underscore says exactly 1. Okay, so I'll write that out. So I know it's hard to see, but percent equals 0 or more characters. Underscore equals exactly 1 character. Whoops, not the plus sign. Okay, so underscore equals exactly 1 character. So percent is 0 or more characters. Underscore is exactly 1. It can be anything. If you want to specify the character, you have to say it. It's a very weak thing. For those of you used to regular expressions, you might say, what if I want to match anything that is CS or accounting? Can I do this? And the answer is no. It will give me nada because it literally needs to see CS bar AC. So the regular expression matching in SQL is incredibly weak. So if I wanted to actually get like CS, I'd have to say like, whoops. Uh-oh. Uh-oh. There we go. I'd have to say select star from courses where course ID like star CS. Darn it. Hate hitting return. Ah. Yep, hit quote. Yeah, it's just frustrating. Okay. Like CS or course ID like AC. And don't get trapped into this. Don't say or like. That's an error message because you have to say it twice.
Can you say
Yes.
like CS for AC?
No, that's what I just did. Oh, I see. You want me to say or like. You want me to say or AC. Maybe. Yep. Nope. Let's put it in parentheses. Probably not. So the answer is it took it as syntactically correct. Nope. So the answer is it said it treated it like course ID, whoops, like CS, and then this was just true, right? Is how it treated it. So it worked, but it was just true. Okay. So we're through relational Boolean operations. You'll remember that I said, let's see, anything else that I'm missing? Going to quickly run through slides to make sure I haven't missed anything. Distinct, calculated fields. Okay. So you'll remember I said it doesn't always have to be a attribute name. It could be a calculated expression. So here I'm doing a simple arithmetic expression to give me monthly salary. This doesn't come up often, but it can come up. Okay, now the issue with that, notice that in the book, it just prints it out as column 4. That's not very descriptive. In MySQL, it would print out as salary divided by 12. This is where using the as is nice. So you'd probably say salary divided by 12 as monthly salary. And then you'd get a nice name. There we go. Salary divided by 12 as monthly salary, and it'll come out now with monthly salary. Okay, moving on. We've already done this and this and this and this. Not in, we've done. But that is actually sometimes. So one of the times you use not is to say not in something, because you want everything but. So then you say not in and you get it, invert it. Okay, we just did that. Nulls. So nulls are interesting. Let's say I have the viewing relation in the Dream Home property management database, and I want to view all comments that were left by customers, but I don't need to see the nulls. I just want to see any non-null comment. Well, you can't actually say where comment not equal null. In this case, I want not null. Let's move this down. Oops. So I might like to say where comment not equal null. That would be what you would expect to work. It doesn't work. Okay? What you actually have to say is where comment not null. It's just it is what it is. You can't use relational operators with null. You have to use the Boolean operators with null. Okay, if I want it all instead where the comment is null, so here I want a follow-up. The client did provide a comment. I want the leasing agent to follow up and get a comment. So I want to find all comments that are null. Again, I don't say where comment equals null. That will not give me the result I want. I have to say where comment is null. Okay, so that's important to remember. If I want to retrieve all null values, I have to say is null. If I want to retrieve all values that are not null, I have to say where not null. Actually, I have to say is not null, sorry. I was wrong before. It's not comment not null. I have to say comment is not null.
Does that mean that the field is not actually storing a null value inside of that field? And then
Yes, it means that there is some meaningful piece of data in that field. that corresponds to a legal value in that attribute's domain. Okay. Just a second. I have to kill this because I forget what it was. Discard changes. I'm going to reopen that. Problem is, I changed the file and now I want to revert it. Okay. Disable macros. Okay, so that was is null, is not null. Okay, ordering. I showed you an example already. So by default, it sorts in ascending order, but if I want it sorted instead in descending order, the keyword is DESC, so that will sort in descending order. Okay, sometimes, let's actually go back to the screen for a moment. Let's select first name, last name from student. So right now it's not in any order, so I could select that from student, order by last name. And order by is not one word, it's 2 words. Okay, so it's sorted by last name, but you'll notice that right here, that's probably not the order we expect to see the names. Why not? We're not sorted by first name, so we're allowed to give it a comma-separated list. And now the secondary sort key is first name. So now it did show up in the right way. Okay, and if for some reason I want it to be ornery, I could say that first name was descending, and then it would be in totally the wrong order, but you get the point. You can always put your primary, secondary, tertiary keys in either ascending or descending order. It's just a comma-separated list. Okay, so now we move into aggregation. So sometimes we want to get the average value of a field. Sometimes we want the minimum value in a field, the maximum value in the field. We may want a sum, or we may want to know the number of tuples that satisfy some filter. In that case, we have these 5 aggregate functions that we are allowed to use. Okay, so to use them, we can, here's an example, select count star from student. That gives me the total number of students, or yep, the total number of students. Or I could say select min GPA, max GPA from student. That gives me the minimum and maximum GPA. So basically you just apply the aggregate function to an attribute. Now that's not particularly helpful. I'd like to know who had the minimum GPA. So I'll say select last name min GPA from student. Looks like Vanderzanden had the minimum GPA. Let's see if that's accurate. Is it? Vanderzanden have the minimum GPA? Whoops. What's it look like MySQL did? It just grabbed the first value of last name from the first tuple. SQL is actually supposed to give you an error message because this is illegal. You're not allowed to include other attributes with your aggregate operations. Kind of limiting, but that's the restriction. So when you use aggregate functions, you're not allowed to use other attributes with them. Okay, but of course, we would like to be able to do that because I'd like to know who was the person who had the minimum GPA. So there are ways to do that. Unfortunately, they're not quite as pleasing. One thing we're allowed to do is we can create variables and store values in those variables. So I will do that. I can say select at GPA colon equals. Isn't that annoying? But you have to say colon equals min GPA from student. And that will store 0.92 into at GPA. So at indicates it's an SQL variable. And then colon equal assigns the value of min GPA to at GPA. Now I can say select last name let's see, GPA from student where GPA equals at GPA. So it's two separate operations. First, I stored the minimum GPA into this variable. Then I put that variable in the where clause, and now I find that it's Bugs Bunny because he's been off torturing Wile E. Coyote and skipping my classes. So he's not exactly been racking up the good grades on the exams. That, and in his essay answers, he was always talking about Wile E. Coyote, and he was off point. So he didn't get good grades. Okay. However, my sweet dog Smiley, because that is what Smiley refers to, is a very smart dog. She's always on point, but she got deductions because she doesn't bring me the ball when I tell her to fetch. So she doesn't get a 4.0 GPA for that. Okay. She's not a retriever, so she still does. She enjoys fetching. She just wants me to come to her. Not very pleasant. Okay. Now, you might be saying that's a little annoying to have to store things. So there is something called we won't do that for the time being. Just, we'll get to it with subqueries eventually. But for the time being, if you want to store or print out additional values, use variables. Okay, so they can store simple values like that.
What if there were multiple people that same minimum GPA?
It works down here. So down here, actually let me insert into student values. Let's see, what's another good cartoon character? Snow White. We'll give her a good GPA. Whoops, I don't want to be. Let's put in here this would be another one getting a low one. Tom Sawyer, also with a 0.92 GPA. Okay, so now if I do my previous selection, both of them come out. So it matches everything. Other questions about that? Okay. So Just a few things to note. Except for count, everything eliminates nulls first. It makes sense. If you're trying to find an average, it doesn't make much sense to be including in the average something with a null value. If you're doing a min, null doesn't have any meaning for min, so they eliminate nulls. Okay? And aggregates operate on single columns. That makes sense too. There's no real good reason to have them operating on multiple columns. Okay? You can use distinct to get rid of duplicates. It has no effect with min and max, but as you might expect, it does have an effect with sum and average, because you might have multiple salaries that are the same, and if you use distinct, that will alter the calculation of average salary if there's several salaries with the same value. Now, did say that aggregate functions could only be used in a select list. I guess I didn't make this point clear. I can't use them in the where. So let's give that a try. Let's say select last name GPA from student where GPA equals min GPA. That obviously would have been simpler, right? Wrong. Invalid use of group function. Why is it an invalid use of the group function? Because you can't use an aggregate function in a where clause. I skipped over that step. So they can only be used in the select list or in a having clause, which we haven't talked about yet. Okay, so I did tell you how to get over that. Okay, here though is an example where you don't just have to do an unrestricted thing, you're allowed to filter the columns first. So here I'm counting the number of properties we have where the rent is greater than 350. So select count star as my count from property for rent where rent's greater than 350. So we have 5 properties for rent that are greater than 350. So we can filter, we just can't use aggregate functions for doing our filtering. Okay, this is nice. Dates are handled, you can use less than and greater than and equal with dates. That's huge. So here I can say, give me all properties that were viewed between the dates of May 1st and May 31st. You do have to put them in a specific order, day, month, year. But as long as you do that, it's able to compare dates. And it does it the way you expect. And you can use less than and greater than. So that's really nice.
You have to use month names, is that right?
Yes, and you have to look them up. So it's usually the first three characters of the month.
For that to work, you also have to declare the column of the date, right?
Correct. For that to work. Yes, you have to declare the column as being a date. Otherwise, if it's a string, it counts it. Yeah, you're right. Okay. So we get to the last thing we're going to discuss today. So sometimes we want to group rows into sets. Like I said earlier, group all tuples from the same branch into a set. And we want to do aggregate computations on them, like sum all of the salaries, or we might want to count of the number of staff at each branch. So grouping allows us to do that. So again, it's probably easiest to start with some examples. So I will start by counting the number of students in classes. So here's student courses. Okay, let's say I want to know the number of students that took each course. Okay, what I could do is say select course ID count star from student courses, group by course ID. And that gives me the number of students that took each of the courses. Now, look at that. I put an attribute in the same select statement as an aggregate operator, and it worked. It worked perfectly. Okay, when I use group by, the rules change. Now I can include anything, any attribute that I put in the group by, I'm allowed to also put it up in the select statement. Which makes sense because I'm aggregating on some or grouping on some column. I would like to print out the value of each set. So in this case, I want to print out the value of each course along with its count. So if the attribute appears in the group by clause, you're also allowed to include it up there. Okay? And let's say I only want to know about courses with an enrollment greater than or equal to 4. I can say having count star greater than or equal to 4. And lo and behold, it works. While I can't put the aggregate function into a where clause, I can put it into a having clause. The having clause is like a where clause. It filters. But now it filters based on aggregation. So where is meant to filter individual tuples. Having is meant to filter sets. So the having clause filters sets. Let's actually put this in a new slide. The having clause, so where clause filters individual tuples. Having clause filters sets. Okay, so it's going to filter out sets. What it really does is it filters out aggregated results, or filters individual aggregated results. So in fact, you tend to put aggregate functions into having clauses. Okay, so this is saying after I have computed my result, the having clause goes through this result and it eliminated anything that was less than 4. So the having clause works after the where. Okay, I can have both. I could have select course ID, count star from student courses, where course ID like CS group by. So the where clause will then restrict me to just CS tuples, and then the group by will group on those common CS ones. So I can use where and having in the same clause. The where operates first, eliminates individual tuples. Then I perform the grouping and the aggregate calculation. And then the having eliminates anything from the aggregates that don't obey the filter. Okay? And then last thing I wanted to say about grouping is don't confuse grouping with order by. They are two separate entities. A lot of times what happens on homework assignments is that students will use group by when they want to sort results. Okay, because it so happens that group by often ends up sorting. Don't use group by to sort, use order by. So here, it just so happened that the results came back sorted correctly. You can't guarantee that. Our MySQL interpreter tends to sort. But to really ensure it, you really need to say order by course ID. Because SQL doesn't guarantee that group by sort. So please, if you're meaning to sort, use order by. Don't use group by and hope that it does the sorting for you. It doesn't always work. Okay? We will pick up with, so we have finished all of the single relation queries. Everything we did today was a query on a single relation. Tuesday, we will talk about queries involving multiple relations because frequently we have to join two or more tables together to get the information we want. So we'll talk about joins on Tuesday. We'll also talk about insert, delete, and update on Tuesday. So you should be able to get started now on the first homework assignment. Axel, you can come up and ask the question. I think you can get everything in the first homework assignment.